The MouldTex project developed an innovative solution to resolve one of the main problems of the rubber seal industry: friction and wear of rubber seals. This H2020 project gathers 4 industrial PMEs: ML Engraving, ORP Stampy, SKM Aeronautics, and Optic. 4 academic establishments: Leibniz University of Hanover, Etanova, Funditech, and Forth, and a competitive cluster, Polymers. Our process begins when a customer asks for a new seal design for his application. His goal is to decrease the seal wear by improving its friction behavior and to reduce the seal's maintenance cost. A study of the application case is made to understand the operating conditions of the seal and its physical characteristics. This step allows the definition of requirements for the seal and to determine if the use case can already be answered by the database of our holistic design software for textured seals. If the use case can be answered by the databases of our models, the new seal can be directly produced thanks to the known seal texture to answer the customer's request. If the use case cannot be directly answered, the new seal needs to be prototyped. Characterization of this prototype will enrich our models and update our holistic design software with new textures. After the definitive selection of the seal design, it will be produced for the customer. During the prototyping phase, we select a DDDR texture and produce prototype molds and seals that will serve as a base reflection for the customer inquiry. The definition of DDDR, diameter, distance, depth, roughness, surface textures for friction reduction analysis, is the first step in the prototyping phase of optimized seals. This process is based on static finite elements method simulation, which reproduce the installation procedure of a requested dynamic seal. The animation exemplarily demonstrates the installation of a pneumatic U-cup rod seal. The decisive output parameters of the simulations are the contact length of the seal in axial direction, indicated by Lx, and the contact pressure level, Pc, between the seal and rod surface. The contact length, Lx, determines the boundaries of the dimple dimensions. Based on the findings of the simulations, a table of relevant DDDR textures is compiled, which serves as input parameters for the prototype mold design and manufacturing process. Working with our customer, the prototype mold is designed according to their requirements thanks to our designing software. The mold is then precisely manufactured following the design requirements. The wide range of machinery that includes lathes, milling, and EDM allows the production plant to select the correct machine basing on the different technical requirement or tolerance and steel characteristic. Finally, the prototype mold passes a quality inspection to check that all requirements are achieved. Following the DDDR definition, the prototype mold is laser engraved to create the textured surface. The laser process creates micro-dimples that will permit the seal to be manufactured directly with the defined surface microstructure. Optical measurements with Filmetrics are made to verify the laser engraving and check that the microtexture is adequate with the DDDR texture selected. As you can see, the result is stable, without recasted crowns and with the same roughness thanks to the grayscale file. In some applications, a mold coating will be necessary to release correctly the seal. This coating is applied to the prototype mold to test the mold release during the prototype phase and to make sure that the mold coating formula is appropriate for the customer use case. To produce the prototype seals, it is first needed to prepare the rubber material. According to the customer's specification, the correct grade material is selected. It is prepared and mixed for further manipulation following industry specifications. The prepared rubber material passes a range of laboratory tests to ensure the quality of the material and conformity for the customer's demand and precisely measure its physical characteristics. The prototype tool is prepared for the molding stage and set in the press. Its temperature is checked to verify that all operating conditions are met. Rubber is weighed and placed inside our prototype mold to be molded into our prototype seals with their defined surface texture. Its release is helped by pressured air. The prototype seal goes under optical measurement to check the quality and the accuracy of its surface texture compared to the DDDR textures selected and engraved in the mold prototype. The optical measure can be done for inner surface textured seals as well as outside surface textured seals. The associated software allows the display of the measurement of 2D high distribution chart as well as a 3D representation of the surface texture. It also permits to visualize the distribution of dimples and nipples of the surface. All data can be exported to an Excel to document the complete structural characteristics of the seal prototype and compare them to nominal values.